Okay, we're creating a video of the 1.1a worksheet to be completed. This is, remember, this is on lines. I do have the assignment always typed up here out of the book in case you lose it, but all of these are on the website. Remember, you can go to the website and print these out. I also have hard copies of the solutions, but the whole idea is to come back and to listen to this if there's anything that you're unsure about. So I'll do more verbal instruction on this, but if you can look at it, see the work, you can check your work using the hard copy. Whatever works best for you in your learning process, just make sure that you do understand the concepts and the process that we go through as we go through these. Okay, this says plot point A and point B, find the slope, and then draw the graph. So if I'm going to plot this, I'm going to go back 2, I'm going to go down 1, is that point right there. Point B, I'm going to go to the right 1, I'm going to go down 2, is this point right here. And I'm going to connect those two lines. Because I'm going to go ahead and do part C right away. Let's me graph it. So get a nice straight edge. Hopefully some of you still have your geometer from your honors geometry class. There it is. Okay? It does want us to find the slope as well. You can find the slope by counting, but when you do that, I hope that you still are practicing subtract the y over subtract the x. So start with either point, doesn't matter. -2 minus -1 becomes -2 plus 1 or -1. And I would just assume you do that in your head without writing it down, but if you have to write it down, that's fine. And 1 minus -2, 1 minus -2 becomes 1 plus 2, which is 3. See if it makes sense. Down 1 over 3, there it is. A lot of times I'll have a blank, and I want you to put it there because when you send me pictures of this and submit online, I want everything to be where it should be for grading purposes. For problems 10 and 12, write an equation for a line that first is a vertical line, then a horizontal line through the point P. This all will be on the test. I'll have blanks for you. A vertical line is simply x equals the x coordinate. A horizontal line is y equals the y coordinate. For problem number 12, the only difference is this is an irrational number, but it's still x equals the x coordinate. Horizontal line, y equals the y coordinate. It's on the first test, that easy of a question, because vertical and horizontal lines come up frequently when we're talking about calculus problems, and we have to know how to write them correctly. Problem number 14 and 16, write the point slope, and notice I wrote linearization form for the line through the point P with slope m. So I want it written like this. I don't want y minus the y coordinate, because then we want to get y by itself anyways. So we're going to do it all in one step. It's going to be the y coordinate plus the slope. Now the slope is a negative number here. So you can either say plus -1, or you could just go subtract 1, whichever you prefer. If you want to just write minus, and I don't have to write a 1 there, x minus the x coordinate. X minus -1 becomes x plus 1. Done. We leave it just like that. Here it is. Y equals, just have to practice it. The y coordinate here is 0. So I just have the slope times x minus the x coordinate. X minus -4 becomes x plus 4. And we leave it. Done. Questions on that problem? Problems number 18 and 20. Write the slope-intercept equation for the line. Now this one, okay, is in slope-intercept form, so y equals mx plus b. Well, they're giving us m and they're giving us b. Y equals m, which is -1, times x. Well, -1 times x is better written just negative x. It's assumed to be a 1, plus b. Done. Problem number 20. Y equals mx plus b. 1/3 x minus 1. Problems 22 and 24. write the equation of the line in point slope. And again, point slope, I actually want linearization form. So I'm just writing parentheses linearization form that passes through the 2 points. Well, I don't know the slope, so I have to find the slope. In order to find the slope, subtract the y's. Y minus the y. 1 minus 1 is 0. 1 minus 2 is -1. But 0 divided by a number is 0. So if I have a slope of 0, that means we have a horizontal line. I'm going to identify this as a horizontal line, because horizontal lines have a slope of 0. Vertical lines have a slope that is undefined. So a horizontal line is y equals the y coordinate. I don't know which y coordinate to pick. They're the same. That's why we got 0 on top. Y equals 1. Done. Good. 24 would be a little bit more involved, because now if we find the slope, subtract the y's. 1 minus -2 becomes 3. Over subtract the x's. -2 minus 2 is -4. So I have a slope of -3/4. It doesn't matter which point we use. We can use either this first point right here, or we could use the second point here. It does ask for it in point, slope, or linearization form, so you do not have to convert these to slope-intercept form. And I really expect that to not be problematic, right? You just have to distribute the slope and add the 2 constant terms together. So for the purple point, y equals the y coordinate plus the slope. Now the slope's negative, so I'll just go -3/4 times x minus the x coordinate. X minus -2 becomes x plus 2. And then the red is going to be y equals the y coordinate, which is -2, plus the slope. The slope's negative, so we'll just say -3/4 times x minus the x coordinate. There it is. For problem number 28, find the slope and the y-intercept and then graph the line. I've provided the graph for you. In order to find the slope and the y-intercept, we just want to write this in slope-intercept form. I need to get y by itself. Subtract the x to the other side. There it is. So essentially we're subtracting x from both sides, but a lot of times I will verbalize that as subtract the term to the other side. Just know that that means we're subtracting x from both sides of the equation, okay, to get the variable x away from y. The slope, therefore, is -1, and the y-intercept is 2. Whenever I ask for a y-intercept, I don't want you to say b equals 2. I always want you to write it as a coordinate point so that we remind ourselves that a y-intercept always has an x-coordinate of 0. So I'm going to go through the point 0, 2, and I'm going to go down 1, over 1, down 1, over 1. Notice that my slope is going downhill. If I have a negative slope, the line goes downhill from left to right. I'll use my nice little straight edge so I get a nice line. Okay. Problem number 30. Same thing. Find the slope and the y-intercept and then graph the line. Well, the slope is 2 because that's the coefficient. And the y-intercept is the point 0, 4. Please always list y-intercepts as coordinate points. Here's 0, 4, right here. The slope is going to be up 2 over 1, so that means if I go down 2, I go back 1. Down 2 is -2, back 1 is -1. -2 over -1 does give me a positive 2. I like to count out as many as I can on my graph so that when I draw a nice straight line. It's as detailed as possible. Questions on problem number 30. Problem number 32 and 34. On both these, we're going to write an equation for the line through P that is parallel to L and perpendicular to L. But this time, we're going to write these equations in slope intersect. Okay. First thing I have to do is figure out what is the slope of this line. So I will subtract the term of 2x from both sides of the equation to eliminate it from this side and create a negative 2x on this side. That means that the slope is negative 2 for the parallel part. And it's going through this line right here, or this point right here. So y equals the y coordinate plus the slope, and it's negative, so I'll just go minus 2, times x minus negative 2 becomes x plus 2. When I subtract a negative, it becomes plus a positive. I want you to be able to do this in one step. I'm starting to believe that sometimes the more you write down, the more likely you are to drop a symbol, to drop a negative sign. And if I just do this in my head, I know, oh, the slope's negative 2x. I get a negative 4 plus 2 is a negative 2. We can distribute and add at the same time because you are all mathematically talented students. The slope of the perpendicular, that's how I like to denote it. Upside down capital T, so I know I'm working with the perpendicular. I've made a different notation for this slope. I have to flip and negate. That's how I get positive 1/2. Y equals the y coordinate plus the slope times x minus the x coordinate, again, is a plus 2. So really, when you think about it, if you write it this way, the only thing that's changing is the slope. It's going to be the same as over here. This time the slope is, oops, and I made a mistake here. This should be y equals, right? I don't want to forget my y equals negative 2x minus 2. Same here. Have to have y equals 1/2 x plus 1. So I can go ahead and write the 1/2 x down. Plus 1, I have to add this 2 to it. I get plus 3. All right? Doing the same process here, but notice this now is a horizontal line. How do I find if it's a horizontal line, how do I find a line parallel to it? Well, it's got to be another horizontal line. How do I write a horizontal line through a point? It has to be y equals the y coordinate. How do I find a line perpendicular to it? Well, perpendicular to a horizontal line is a perpendicular line, or is a vertical line. How do I find a vertical line through a point? A vertical line through a point is x equals the x coordinate. Done. That easy. Problem number 36. This is the same process that we've already done. But a lot of times if we have more than one point given, it tends to confuse students. Don't let this confuse you if they want the equational line with more than one point. It's the same process. Find the slope between 2 points. How do I find the slope? Subtract the y over subtract the x. Negative 4 minus negative 1 becomes negative 4 plus 1, which is negative 3. So over subtract the x's, which is 2. Now, if it's a line, it should be the same thing here. Negative 4 minus negative 7 minus negative 4 is negative 7 plus 4 is negative 3 over 2. Yeah, doesn't matter which points you use. Now we have 3 options to put it in our point slope or linearization form. We can use this point, or this point. They will all produce the correct line. Why not use the easiest numbers? These are smaller. So y equals the y coordinate plus the slope, and the slope's negative, so I'll just say subtract 3/2 times x minus the x-coordinate. That is linearization form, which is point-slope form with the y-coordinate on the right side. Negative 3/2 x. Negative times negative is positive. The 2's cancel. I get a positive 3 minus 1 is a positive 2. That means the slope is negative 3/2 and the y-intercept is positive 2. Now when they say b equals, you can just leave it like that. You don't have to write it as 0, 2. But any other time that I ask for intercepts, please write them as coordinate points. For problem number 38, find the value of x for which the line through A and B has the given slope. Now I also teach SAT prep, is my other class that I teach. This type of problem is on the SAT test frequently. So some of you are going to be taking the SAT test perhaps for the first time in the fall. Okay? So we do it the same way. To find the slope, I always start with the point that has the variable. Subtract the y's. 2 minus negative 2. 2 minus negative 2 is 2 plus 2, or 4. X minus negative 8. X minus negative 8 is x plus 8. Minus and negative becomes plus and positive. And then I set that equal to the slope. Now I just solve this. So I can figure out what that x-coordinate is that's missing. I'll multiply both sides of this equation by x plus 8. I will distribute 2x plus 16. I will subtract the 16 from both sides of the equation. 4 minus 16 is negative 12. And then divide both sides by 2 to get that x equals negative 6. Okay, questions on that? 47. The slope of a vertical line is 0. Justify your answer. These are true or false. Are there any true or false on the AP test? No. All multiple choice or free response. Okay? But these are still good questions, and there's some of these on almost every assignment that I expect. Okay? So the slope of the line of a vertical line is 0. That would be false. The slope of a vertical line is undefined. And that's what you'd say. The slope of a vertical line is undefined. Okay. 48, true or false? The slope of a line perpendicular to this is 1 over m. Justify your answer. Again, this is false. If the slope of this line is m, that means the slope of the line perpendicular is negative 1 over m. Okay? And that's good enough justification. Anytime that you can use mathematical symbols to justify on the AP test, we want to do that. It's shortcut. It's really just shorthand notation. So we want to get used to doing that. 49. Which of the following is an equation of the line through this point with a slope of 1/2? Notice, some of these are in point slope form. Now you just do have to remember this is y minus the y coordinate. So I need a y minus 4. These two are out. Okay? I need an x plus 3. X plus 3, x plus 3, x plus 3. They're all still in. But the slope has to be a positive 1/2. That's got a slope of negative 2. That is a slope of positive 2. There it is. There's the slope through that point. Okay? 50. Which of the following is an equation of the vertical line through this point? And again, you'd be surprised how many students will miss this. A vertical line, x equals the x coordinate. Done. Now, there's several multiple choice problems where you will need to show more work. But when I do these, I'm going to try to make it as realistic to the test, to the AP test as possible. And don't show work if you don't have to. Which of the following is the x-intercept of this line? A lot of students will just jump on -5. That's the y-intercept. X-intercept can be found by plugging 0 in for y. Whenever I want to find an x-intercept, I plug in 0 for y. Whenever I want to find a y-intercept, I plug in 0 for x. It's just the opposite. So add 5 to both sides of the equation and divide both sides by 2. 5 halves. Okay, that's choice D. And the last problem on this set, which of the following is an equation for the line through this point and parallel to this line? Well, if it's parallel to this line, it has the same slope. It's not perpendicular. We have to be very careful. As a matter of fact, I should be highlighting that word, and you might want to do it every time. So you make sure you know. Are they asking about parallel, or are they asking about perpendicular? So parallel has the same slope, but it's going through this point. These are written in slope-intercept form. So it's easier just to start with that linearization form as opposed to the point slope. It's easier just to say this. Y equals the y-coordinate plus the slope. Now my slope's negative, so I'll go subtract 3 times x minus the x-coordinate. X minus -2 becomes x plus 2. I think you should be able to do these two steps without writing it down. But for this one, I'll do this. I'm going to subtract -3x. -3 times 2 is -6. And maybe some of you need to. -6 minus 1 is -7. That's why we get -3x minus 7. Choice B. Those are the solutions for this one. I'll be asking you to send pictures and send it to me, and then you'll see how this goes each time that I create a video for these. I do want to give you this warning. Most of the other worksheets, I'm going to have the work already done and just talk through it. And the only reason that I'm doing that is so that the videos themselves are a little bit cleaner as I talk through it. I'll still highlight some areas. I will talk about where common mistakes occur, and that's why I'm doing this verbally. Remember, all of these are on the web page and are completed as well as a hard copy. But you have to know which problems you need more verbal explanation for, and then come back and look at the video and see if there's something that I'm saying verbally that will answer your question for you. Okay? All right. That's the end of this lesson, and we'll pick up with the other ones later.